Hello everybody. So let's start the solution of this problem. It's a weekend challenge number 4. Lx square nx plus n equals 0 equation is given to you. The roots ratio is p to q or p over q. So then prove that this relation p over q square root plus q over p square root minus n over l is equal to 0. So let's suppose first of all, let us suppose the roots of this equation are alpha and beta. So if alpha and beta are the roots, then if I will rewrite that equation, so that will change to x squared plus n over lx plus n over l is equal to 0. So then sum of roots is going to be negative n over l, negative n over l, or you can say alpha plus beta is equal to negative n over L. That's my equation number 1. And product of same roots is equal to C over A. That's in here N over L. So it means alpha into beta is equal to N over L positive. Equation number 2. Also, one part is given to us. Alpha over beta ratio of the roots is P over Q. That's, let's say, equation number 3 for us. Now I want to prove that relation. So what I'm going to do, let's solve this binomial, will help you to understand how to solve this question. So P over Q square root plus, let's choose Q over P square root whole square. How to open this binomial? From where I took it, it's given in here. If you will see, this is right here. So I'm highlighting this part, these two sections I took with the squares. Then what's going to happen? So I will write P over Q whole square and plus Q over P whole square, and we have square root of both of these issues, and plus double of P over Q square root into Q over P square root. So in general, so these square root terms are going to be cancelled, and you will have 1 in here. So this is equal to P over Q, square root and square, they will cancel each other. And plus you have Q over P and plus 2. From number 3, so I can replace this P over Q by alpha beta. So first part is alpha over beta, second part is beta over alpha and plus 2. If I will go for LCM, LCM is alpha into beta. You will have in the numerator alpha squared plus beta square plus 2 alpha beta. That's a perfect square trinomial again. So this is going to be alpha plus beta whole square divided by alpha into beta. So now from number 1 and 2, I can replace sum and product of these two roots. So that's going to be equal to negative n over L whole square. That's the sum of roots over n over L. So 1 n over L is going to be cancelled. So this is equal to n over L, just 1. Now if we will go back to the original equation, that was P over Q. So therefore P over Q square root plus Q over P square root is equal to, whole square is equal to n over L. Now I can remove that square root by doing square root on both sides. So therefore, so I have P over Q square root, P over Q square root plus Q over P square root is equal to n over L square root. I'm only considering positive option. I'm not going for negative. So that means this is P over Q square root plus Q over P square root Bring other term on the left side, that's n over L, square root is equal to 0, and your relation has been proved. So your left side and right side are equal now. So now you can check from the beginning. So what I did, alpha, beta, I scored the roots of that equation. I found sum and product of those roots. Then I picked the first two terms, the highlighted one from the relation which we want to prove. And then I tried to solve it, replaced the alpha and beta instead of P and Q, and came up with sum and product in the solution. And then automatically whatever required information was explained. So this, I hope you like this relationship of different parts of the quadratics. And if there is any question, concern, you can write in comments. But enjoy your math. This is another challenge. So I hope you enjoyed. Thank you very much. Have a nice day. Bye.